the group selection that's sneaking back into the field is very different. Two different versions. First one, something you will get in various populations. You've got a population of something or others, and some biogeographic event occurs which causes a subset of them to get isolated from everybody else. A land bridge disappears, or somebody drops a lake there, or who knows what, but something isolates a small subset of the population. So these guys go about reproducing by their standards, and these guys go about reproducing by their standards. And what's going to be a characteristic very soon of the smaller population, they're going to be more inbred than this population, simply because they're smaller. They're going to have a higher degree of relatedness among individuals. So now we throw our second piece of our three building blocks, throw in kin selection, and what that immediately predicts is levels of cooperation will be higher in this group than in this group, because the higher degree of relatedness. That's great. And that's great because once we see how sort of cooperative systems have a larger payoff, you will get a crystallization so that everybody, the second or third cousins, are eventually going to have to be just as cooperative as the siblings are with each other. You are going to fix a trait of cooperation in that population at a high rate. So notice here, in this case, we have a high degree of cooperation driven by kin selection, whereas these guys are going about their usual savage at each other's throats business. Biogeographic event reverses, and these guys get reincorporated into the main population, and they're so different by then that they get a different color. And what you've got then is, here in the large population, here is a nucleus of animals who are cooperating. And here is the huge unwashed mass of the ones who are not. And everything we know about reciprocal altruism, all of that means that these guys are going to start outcompeting these guys. And the model that is used is cooperation will have to crystallize outward. Animals will have to join in these cooperative patterns because these guys will outcompete them. What do we have? This is called a founder effect. This is a small population that, thanks to being inbred, has fixated some trait that's advantageous, where the evolution here moves faster than in here because of the smaller population with the inbreeding. Some adaptive trait comes in there, they get reinduced into the main population, and this founder-driven trait quickly spreads throughout the population. And what you get here is, if the same thing is occurring in the realm of behavior, reciprocal cooperative behavior, somewhere in here you have a transition from this being a kin selection phenomenon to this being a reciprocal altruism phenomenon. So that stands as one of the models out there for how do you jumpstart cooperation in non-relative populations. You use inbred founder populations to drive it there. And just to have a metaphor, all you need to do, think about in some city, there's some occupation, some mercantile, something or other, that there's a gazillion of them and all sorts of people work in that, and there's a subgroup of people there who work in this who are all related. And as a result, they do something cooperative and kin selective. They make low interest loans to each other. And as a result, they're more successful at business. And they get incorporated into here, and what you then have is this economic force that everybody else has to join in to this cooperative business of trusting each other, or low interest loans, or I trust you like a sibling, you don't have to pay me until next week. Used to be that only siblings trusted each other like siblings, but a force there for more cooperation, a driving force of inbred kin selection initially. So that's one way in which people are thinking about group selection, and here you now have this group outcompeting this because of this trait, and people actually use terms like crystallization. The trait of cooperation will crystallize outward and fix in the whole population. So that's one version of it. And this is one, again, we will come back to. This is one of the ways to jumpstart cooperation in a world in which there is no reciprocal altruism. Because you see the problem with that. We all have learned tit for tat is the best one, except forgiving tit for tat might be better, except Pavlov might even be better. And all of those are built around this one requirement, though, which is somebody has to make the first move of being cooperative. That's got to jumpstart the system. And what we all know is, in a system that doesn't go along with the rules of can't we all sing Kumbaya, what happens is the first one in the first round who does something cooperative is some schmuck who's one step behind everybody else for the rest of time. There's no way to get these cooperative systems to evolve initially. We'll see there are ways, and this is one of those. Have it driven initially by kin selection, and then throw it into the general population. So that's one version of where group selection is crept back in. Another version is sort of the more generalized form of it. And it could be illustrated, okay, the following example. You've got chickens. You've got chickens with an array of traits, and you can see there's two types of chickens. One chicken is super aggressive and beats on everybody else, and she lays lots of eggs. Another chicken, far more pacific and introspective and less aggressive and has fewer eggs. So now you take any one of the high aggression females and one of the low aggression guys and put them together, and who's going to leave more copies of her genes? The high aggression female laying lots of eggs. Now instead, you have a whole group of the high aggression females and a whole group of the low aggression females. What's going to happen in the high aggression females? They're all so aggressive that they all injure each other. They all stress each other into lower fertility rates, all of that. And suddenly you have this very important world in which A can dominate B, but where groups of B dominate groups of A. And it's in that realm that you suddenly get a push towards group selection. When selection on that level, a world of any individual being out-competed because of a trait, but as a collective, and bringing in that word, not randomly, as a collective in the collectivist future of low-ranking chickens to throw off their chains. Once you have a group of them, the same traits that could be disadvantageous on an individual dyadic level, as a group outcompetes the others. And when you do that, you've suddenly got group selection in a classical form where these animals, because of their traits, they are not behaving for the good of the group, but the very traits that are disadvantageous individually are advantageous as a group. And it's another way of thinking about this. If you indiscriminately make low-interest loans to everybody on Earth, you are very readily falling into this category. If you are part of a group that makes low-interest loans to each other, suddenly you outcompete the other. Fascinating book, Evolution.